Hi and welcome to a science video on electricity, or rather a science lesson on electricity. If you watch my previous video, you remember that I mentioned we will approach this in question-based style, but I think it's also good to review some of the main concepts first. Alright, so if you find my videos helpful, please do subscribe because you do not want to miss any videos that I upload. Okay, so here, please subscribe. Alright, again, I'm gonna try to keep to about 20 minutes or so. So let's go. So I think this video should be short because we're just gonna talk about the main concepts here. And the next video then we'll attempt some questions and see how to answer them. So in this topic, what you need to know is you need to recognize that an electric circuit consists of an energy source, usually a battery, and other circuit components. So the name is quite important. Whatever that other things that you put in the circuit, they are called circuit components, and they consist of wires. Even the wires are component, bulbs and switch and some other things, okay, to form an electrical system. So a simple one would be, you also need to know how to construct a simple circuit using circuit diagram also. Alright. Investigate the effect of some variables on the current. Okay, so number of batteries and number of batteries arranged in series and number of bulbs arranged in series and parallel. So you do not need to know about batteries arranged in parallel. Okay, later we'll talk about what series is, what parallel is in this video. Okay, and know how to conserve and proper use of handling electricity, value individual. Okay, so this last part is not part of the objective. Alright, we'll talk about this first part here. I've not talked about these two yet, so we'll talk about this first part here. Now, sometimes they can be drawn in this manner, okay, which is by, you can say, drawings, okay, represented in drawings. Okay, so this is my bulb here. Okay, that's my battery. Okay, sometimes they can draw a switch, but you don't need a switch. Alright, remember that you don't need a switch. So this is what we call a sample of circuit diagram. Sometimes they can use symbols. So you need to know the symbols. This is a symbol for battery. You can check out the notes in the description. They have all these things here. Okay, so this is how the bulb looks like. Okay, again, I'm going to try to keep this short. It's just a recap of what you've learned. And this is how they look, okay, when you draw them using the drawings and then with the symbols. Now the bulbs, you can see here, it's connected in a specific way. Alright, the reason is because you need to make sure that it forms a closed circuit. Alright, later I'll touch on the closed circuit part here. The inside of the bulb is like this. So one of the wires that's connected to the filaments is connected to the tip. The other one is to the casing. So when you join, you have to join in such a way so that it forms a closed circuit. That means the electricity can flow in the loop like that. Okay, so that when the electricity flows, it flows in the loop. Okay, let's say it goes from the battery, it goes here, it follows, see, it's connected there, and then it goes here and back to the battery. So we call this a closed circuit. Okay, so what happens if you do not connect it like that? For example, let's say you connect both to the metal casing. So if you connect both to the metal casing, okay, so now we're going to focus only on the red line, and you see what will happen here. when the electricity tries to flow here, there's no connection here. It stops there. So we call this an open circuit. Alright. You can form an open circuit if you do not connect the components properly, or if you use a switch. A switch can open or close a circuit. Alright. So these are some of the components. And for switch, okay, usually it is drawn as a symbol like this. Okay, hold on. Okay, this is an open switch. Okay, of course you connect the wires there. And for a closed switch is just like that. This is a closed switch. Okay, next we talk about just now how when you connect the bulb properly, it forms a closed circuit like this, where electricity can flow. So that brings us to a key phrase, which we will elaborate more in the next part, where we'll answer some questions. So the key phrase is, if let's say anytime the component works, let's say the components here in a circuit here, we are talking about a bulb. If the bulb lights up for whatever reason, we say it forms a closed circuit and electricity can flow. So that's the key word there. I mean the key phrase. Okay, again we're going to talk about it more when we attempt some questions. Here I'm just going to go through briefly. Okay, so you say this is the first key phrase here. You'll use this a lot in this topic. You can say electricity can flow as it forms a closed circuit. Okay, and that is if the components work. If the component is a light bulb and the light bulb lights up, we say it's because electricity can flow as it forms a closed circuit. If it doesn't work for whatever reason, okay, usually we will say as electricity cannot flow as it forms an open circuit. Okay, you can write it the opposite way also. For example, you can say as it forms a closed circuit and electricity can flow. Okay, and the other one, okay, try not to start with it. So we start with as it forms an open circuit and electricity cannot flow. Alright, either way is fine. So only when it forms a closed circuit, then electricity will flow and the components will function properly. Alright. Next part here is how number of batteries arranged in series, okay, are affected. If you have, let's say we put 2 batteries here, okay, and then we put 1 bulb here. Okay, now we'll learn how to calculate the unit of electricity that passes to the light bulb. We have 2 batteries sharing with 1 light bulb here. Okay, so that means we have 2 batteries sharing with light bulb, 1 light bulb. That gives 2 units. 2 over 1 is 2 units here. So 2 units of electricity passes through this light bulb here. If I add 1 more battery, that means I have 3 batteries passing through 1 light bulb. That will give me 3 units. So if I add battery in this manner, the light bulb will receive more electricity. That means it will become brighter. Alright, so straightforward. More batteries, brighter light bulb. But of course, up to a certain point, when there's too much electricity, electrical current flowing through the bulb, it will melt the filament. And when it melts the filaments, the bulb doesn't function. And when the bulb doesn't function, what do we say? We say it forms an open circuit and electricity cannot flow. Now, what happens if we arrange the bulbs now in series. Okay, before that, series and parallel. Okay, so series and parallel. Okay, we talk about series first. Series is very direct. When we say the bulbs are arranged in series, that means when the electricity flows and it flows in that loop or in that circuit, it flows through all the bulbs. That means the bulbs are in series. So again, for this case here, when the electricity flows, it has to flow through bulb A, bulb B, bulb C, and back. So we say all these three bulbs, they are arranged in series. Okay, what happens if they are arranged in parallel? So if they are arranged in parallel, okay, I'll try to squeeze here. It will look something like this. Okay, after this, then we'll talk about the effect of bulbs arranged in series and parallel. Now, if you look carefully here, they have their own loops. Okay, the electricity will flow through here, and you see it doesn't need to flow through the other bulbs. Okay, so this is bulb A, and when it goes through bulb B, it doesn't need to flow through any of the other bulbs, and same for bulb C. So we say bulbs A and B and C, they are arranged in parallel. Okay, they are arranged in parallel. So what are the effects? Why do we need a parallel and a series circuit? Now, very simple. If we have one bulb arranged like that, okay, just now we talked about one battery shared with one bulb or passing through one bulb. This is 1 unit. But if we have two bulbs, let's see what happened here. So when the electricity starts to flow, okay, electricity will flow through, okay, let's call this bulb A and this is bulb B. Okay, it will flow through bulb A and bulb B. So this one battery has to flow through, it's one battery. This one battery has to flow through two bulbs, and that means each bulb is now half a unit. Look, before it was 1 unit when there's only one bulb, but now it's half a unit. So when you add more bulbs in series, what happens is the brightness decreases. Let's check what happens if we add them in parallel. Okay, again we start with one bulb, one battery. So this is 1 over 1. One battery flowing through one bulb, 1 unit. If I add another bulb in parallel, so let's check to make sure this is parallel. Alright, so what happens here is I can flow through this circuit here. Again, we call this bulb A and bulb B. Let's name them first. Bulb A and bulb B. Okay. When the electricity flows through bulb A, it doesn't need to go through bulb B. So that means these two bulbs are arranged in parallel. Now, what happens if we arrange the bulbs in parallel? When the electricity flows through the first path here, one battery flows through one bulb, 1 unit. And when it goes to the second one, again the same thing. One battery needs to flow through only one bulb. So this is 1 over 1, so it's 1 unit. So this bulb gets 1 unit, this bulb gets 1 unit, compared to this when you have two bulbs. Okay, so let's erase this so we are not confused by this. Here, one battery flows through two bulbs, 1 over 2. So we get half a unit. And if I add one more, what happens is the same. The electricity, when it flows through this last bulb here, we call this bulb C, we have one battery only flowing through one bulb. Okay, you can see, when I trace the circuit, I only need to trace and pass through one bulb, because they are all in their own separate loop. So this is again 1 over 1, 1 unit. Okay, but if I add a bulb here, now when the electricity flows, it has to flow through 3 bulbs. So this is 1 over 3. That means 1 over 3 units. Okay, no longer 1 over 2. So let's just change this to 1 over 3. And you can see, the more bulbs you add in series, the dimmer it gets. But when you add them in parallel, it remains the same. So why would anyone use series instead of parallel? Because when you use parallel, this bulb gets 1 unit, this bulb gets 1 unit, this bulb gets 1 unit. Total will be 3 units. As for this one, 1/3 plus 1/3 plus 1/3, total is 1 unit. You use less electricity over here compared to here. So if you use a battery, the battery will use up all the energy faster if you arrange the bulbs in parallel compared to in series. So that's one disadvantage of arranging the bulbs in parallel. But there's another advantage. For example, this bulb fuses, bulb C fuses. Okay, so when it fuses, you can't use it anymore because the filament has melted. Okay, and look at what will happen here. When the electricity flows, of course it will not flow through C. Okay, but electricity will have no issue flowing through bulb A and bulb B. So if bulb C fuses, bulb A and bulb B can still light up. But for this case, when they are arranged in series, if this bulb fuse or any one of the bulb fuses, straight away electricity will not flow because it doesn't form a closed circuit. Okay, so again back to the keyword, it doesn't form a closed circuit, so electricity cannot flow. As for the bulbs arranged in parallel, we can say as it forms a closed, or we can say there's more than one path of more than one path for electricity to flow, so it forms a closed circuit, or you can say so it still forms a closed circuit and the other bulbs can light up. So that's something I added there. I added forms, there's more than one path for electricity to flow. Again, we will focus a bit on the key phrases when we do the answering technique when we in the next part. Okay, so we know about the components. Okay, we know about closed circuit, why it can only flow in closed circuit. Okay, we have talked about how the circuit diagram looks like, and we talk about the effects of batteries in series and bulbs arranged in series and parallel. Okay, the last one is very simple. We're going to talk about conductors and insulators. Basically, conductors, most metals are conductors. That means they allow electricity to flow. And most non-metals are non-conductor. I think most non-metals are non-conductors. Okay, but there are non-metals that are conductors. Okay, for example, water can still conduct electricity. Graphite, alright, can still conduct electricity. So what happens if you put an insulator in place of the wire? So for example, let's say if this is an insulator, we place it here. So now electricity cannot flow. When electricity cannot flow, that means because it forms an open circuit, the bulb will not light up. But if you put a conductor here, okay, electricity can still flow, no issue, the bulbs will light up. Alright, so basically that's it. And in the next part, we will talk about how to approach some questions in this topic. So do subscribe so when I update the videos or I upload new videos, you'll be notified. Thanks for watching and hope this was helpful and clear. And if you have anything you want to say, alright, please leave them in the comment section below. Thank you.